want to look at how we're going to fit a straight line into a set of data points. For example, if we should have a graph as thus, and you have different data points. So you have a data point here, you have a data point here, just different data points on different points on the graph. Now, we want to fit a straight line on this graph, having various data points. How do we do that? You don't just fit a line here, or you just pick any 2 points. You might come into an error, maybe because some of those points may be outliers. So what do? You need to do what we call sum of squares. Sum of squares. Because we're trying to fit a perfect line here. And we need to pick, we don't just pick any data point. We need to find the mean of all of these data points. And we'll be using a function as this. Just like the previous example, why are we squaring our data points? We're squaring our data points so that we don't knock off certain data points. For example, if you have a data point as -3 and +3, the moment you sum this up together, it tends to 0. Automatically, you've knocked it out. So what we have to do is we have to square each of these data points. And when you square -3, you have 9, and then you have 9. So that is why we are going to be using sum of squares, using this particular function. Now, remember that the equation of a straight line is giving us y equals mx plus c. Some textbook you might see b, some you can see k, but remember that this c means the y-intercept. Y-intercept, your m is your slope or your gradient. Y is your y value and x is your x value. So, like I said, in different textbooks, you could see C, you could see B, you could see K. Most cases, you see M as your slope. Reason, I don't know, but if anybody can tell me why M is for slope, please hit me up and I'll be glad. So yes, back to what we're doing. We want to fit a straight line on this and using sum of squares. So what we do is we have data points. And remember, each of these data points are coordinates. We have x1, y1, x1, y1, or rather, let's call this x2, y2, different data points. So we're bringing these data points together. We're going to be summing them up. And then we have something like x1, y1, x2, y2, all up until xn, yn. We're going to be summing all of this up using this equation. So we're going to be having something like y1 minus mx1 all squared plus y2 minus mx2 all squared up onto yn mxn all squared. Sorry, I ran out of space. So we continue from the last equation where we have our summation of our data points. So we'll be having y I minus mx1 all squared plus y2 minus mx2. You sum that up into depending on the number of data points you have on your graph. So that'll be yn minus mxn all squared. There's a long expression, but it can be shortened to give you a summation, right, of yi minus mxi all squared. Now, this is an expression of the function we had initially, the example we have where we have 4 minus 2m at our earlier example. So this is an expression here. And remember, we're trying to fit in a line on this graph. So say we're trying to fit in a line on this graph we have here. And remember, equation of a straight line, y is equals to mx plus c. Please don't forget to tell me what m is, right? Now, for this c, it tends to 0 because it has to cut across c being our y-intercept.
For this example, in order to simplify, we assume that c is equal to 0. This means that the line we are fitting goes through 0 like this.
Now, what are we trying to do? We're trying to find the distance of this data point, the distance of this data point between our line. Say, we do something like this, right? Something like this. We're trying to find the distance between this data point and the line we've been given. But how do we get to know this line? By finding our slope. Remember from this example, which we gave earlier, we needed to find the derivative. Hence, we need to find the derivative of this function. And so we say the derivative with respect to m, we say dm is going to be equals to, say, minus 2x1, right? y1 plus 2x1 squared, right? And then you have your m. Because when you differentiate this, you get this. Remember, we are picking each data point. So this is for one data point. It's all squared. This is a summation of all the data points. And then you have, this expression comes down, it continues like that, minus 2x to y2 plus 2x2 squared m. And then it goes all the way like that, right? So minus 2xn, like I said, where n represents the number of data points, 2xn yn plus 2xn squared m. Now, you don't bother yourself about this whole expression, right? All of this can form, so the whole of this will just become a summation of 2xi yi minus the summation of 2x squared, remember I, and then your m. So now this is the derivative of this function here. The derivative of this function is this.
For you to find the slope which makes the line closest to the point, this derivative has to be 0.
That's the minimum value has to be 0 rather. And for that, you have to make your derivative. Remember, the derivative here is your slope. So you equate it to 0. So automatically, this becomes 0. So equals to 0. Now we are finding m. Now we have this expression. We want to make, like our mathematics, we say, making m the subject of the formula. So we bring m to the other side. So you have a summation. This expression, 2xi y1 is equals to the summation of 2x squared I m, right? If you remember mathematically. So what do we do to make m stand alone? You divide both sides by this, the coefficient of m. Now with this we cancel this. M is standing alone. 2 here, kick out 2. So automatically we have, let's come to this side. We have m. Now our m is equals to the summation of 2 multiplied by xi yi, right? Divided by the summation of x squared I, right? With your I and your n. So this will be your expression for m. So that's will be the expression for m when you want to fit in a straight line in your graph.